Okay, we're now at 25.2, so I shall begin. Hello, everybody. Thank you for coming to this webinar. You can't sit with us, creating a socially distanced seating plan generator with Alteryx. So a bit of a background about this. So for those who were not who don't live in the UK, essentially, at the start of the pandemic, I think it was in March, we went into what we now call the first lockdown or high lockdown. And, everybody was in their homes. They could only leave for an hour's exercise, or if they really, really had to go to work and it was a key worker, an essential worker. But apart from that, you had to stay in your homes and everything was cancelled, including church services. Now, in the UK, the nations left lockdown at different pieces at different times. But in England, I think was the first of the 4 nations to leave lockdown. And a few weeks before that begun, that gradual easing of lockdown, there was a bit of a conversation I was having with my church on Zoom. Would you believe? So we're having a Zoom chat. This was kind of replacing the coffee chats we would normally have. So the service was broadcast, and after the broadcast, we would then all meet for your little coffee and biscuits, as you tend to have in cute little churches. And we were doing that, but virtually, and we're having a conversation about what we're going to do in order to make sure everybody who wanted to attend service after lockdown could attend that service. And the big question is how can we maximize that using the household rule? So the rule that came out at the end of lockdown in England was that in churches, if you are attending a service, you can sit with your family, your household, or your support bubble. And the support bubble is sort of the household plus maybe another person who possibly lives alone or is vulnerable. But yes, so bubbles or households could sit together, and then there had to be about 1 meter's distance between the households. So you could have one person, another person, and then a household, but there had to be distance between all of these people. I saw someone raise their hands. If you could put questions in the Q&A, and I'll come to them at the end. I definitely won't ignore them, so don't worry about that. But the problem was that we had is, well, different households could come at different times. Well, they won't be the same people every week. How do we know? How can we predict that if we're going to sort things out? So my suggestion was actually, in Alteryx, I could possibly build a seating plan generator, where I could build an app that would tell people where to sit in a way that would maximize the space available, so you could have as many people attending services as possible. So let's have a look at how I did that. So this had to be split in 2 parts. I needed 2 separate apps that did 2 separate things. And the reason I did that is because it actually ended up minimizing the work that the end user would have to do. So in part 1, what I needed to do was to actually create the church itself as a spatial object. So the reason I needed to do that is because, I can't understand where to plot people until I actually have the shape, the dimensions, till I know how big the church is, the shape of the church, and where people can actually sit. So the first thing was really important, was to actually create the church where we're going to put everybody in. So how did I do that? You may be asking. Well, here we go. So these were the steps that I took. Create a spatial object representing the entire building, then to create exclusion zones in that building. And exclusion zones are very important. So what I mean by that is these were spots where people could not be seated. So maybe there was a pillar there, maybe there was an altar there, maybe there was a big statue there. You don't want to sit someone on a statue. That would be very, very uncomfortable. So we needed these exclusion zones that would say people cannot sit here. Then what we do is we cut those exclusion zones out of our spatial object, and then we create the product of that into a grid. And that grid would represent the seats. Every square would be a potential seat someone could be sat. Okay, so creating the spatial object representing the building. This meant digging out the blueprints, going into the archive, talking to the architects who had been doing some studies of the church, talking to them and saying, okay, can we have some blueprints? And then what we needed to do from the blueprints was to do a few things. First of all, we needed to decide what the center point was, and this could be arbitrary. I think for a church, it made sense that, you know, this would be where the altar is, or where the podium is, sorry, for where a sermon is given. That seemed to make the most sense. So you can see here my center point in here. You can see this is where the rector of the church, rector being a vicar, would stand and, you know, give his sermon. Then what I needed to do was work out, okay, where is north? And we needed a straight line so that I could then use a protractor when I dotted the points. Because what I wanted to do for each point was I wanted to collect 2 bits of information. What is the distance between the center point and an end point? And these end points would be the outline of the church. And what is the angle? And that's really, really important because we'd have to orientate it. So how this would be orientated is 0/360 degrees would be exactly west. North would be exactly 90 degrees. East 180 and south 270. And luckily in the blueprints it did include a compass, so we knew exactly how that was going. So with this dotted line you can see kind of going down the blueprints, what that did was I'd put my protractor to face either 90 degrees, or that would align to 270 degrees. And so I could then look at the angle of each point. I would draw little lines for each point, measure the points, measure the distance, then work out the degrees. And I would want it to look a little bit like this. So we had a point ID so that we know which order to dot these in. The centimeter distance on the blueprints between the center point and the outline point, and the angle of that. And then the label was quite unnecessary, but I put it in there just in case. So to create exclusion zones was pretty much the same kind of process, except that obviously instead of being the outlines of the church itself, it was the outlines of anything that constituted a barrier. So, you know, your pillars, your altars, all those sorts of things. And the only difference here is that we needed an object number. So you can see we've got 1111. Equally, this could have been, you know, this is column A, this is statue B, could have done that, doesn't really matter. But what was important was to have something in the data that distinguished each exclusion zone. And it was really important that they were individual objects that were not going to be confused with each other in any way. So I used object numbers, but an object ID could have been fine. A label like pillar, altar, that would have been fine as well. So we used both to create points, and it was really just kind of a copy and paste kind of job. So what we needed to do is to convert the centimeters into kilometers. So you needed the scale of the blueprints. We assumed the scale was 1 centimeter equals 4.73 meters. Turns out we were wrong, so we were wondering why the church seemed so small. It's because we were wrong, that's why. But it was okay because we turned this into an app so that the user could you know, put in their scale. So it wasn't really a problem that the actual scale in the app was wrong, because it was adjustable. The user could change it. So then the other thing we did is use the map input tool. So this was going to pinpoint our center point. And when I demo this, you'll see what I mean by that. But we pinpoint the center point on an actual map, and that would then, would help with our calculations. That center point needed to be appended. We need to get the longitude and latitude of that and then append that to all of our points, because we're going to use that to calculate. We're going to use that to sort of say this is the distance everything is from that center point. So every single row of our data needed to have our center point on it repeated for each and every single one of those rows. Then we did the trigonometry. I'll go into the trigonometry. If you want to do this yourself, I've got a blog and you can copy and paste the trigonometry. I suffered and suffered. It took me hours and hours to find out, to understand, to work it all out. But I eventually got there and it was all good. So you could copy and paste the trigonometry yourself if you want to do this yourself. But this is where it would go into trigonometry, and the trigonometry would work out, okay, using the centimeters and the angle, what is the longitude and latitude of each of those points? So it would use that center point, use the centimeters, use the angle, and it would produce a new set of coordinates, a new longitude and latitude that represented each point in the world, which would make up the church and would make up the exclusion zones. Then after that, what was necessary is to create points and then polybuild tool. And the polybuild was going to put those together. And it used that object ID to kind of say, okay, there's point number 1, connect that to point number 2, connect that to point number 3, etc., etc. And so you had an outline of a church. This is the trigonometry. So these are in the formulas. This is what needs to be done. One point I would make is one bit of this, and this is this 6365.086 bit. This is adjustable, so that number is going to be determined by how high your building is. So if you're doing this for an office, how high is your office above sea level? Now, this is normally done by city. You don't need to literally specifically work out how high your building is above sea level. The reason that is relevant is because the Earth is circular. To increase the accuracy, you're going to need to adjust this value to make sure that, because a certain bit of distance is going to produce this doesn't like correspond. So if you're like a meter away in one part of the world and a meter apart in the other side of the world, but they have different they're in different parts of the Earth, then it's actually not going to produce the same kind of changes in your longitude and latitude. It has to have this little dynamic element in. But there's a website linked in the blogs where you can find that out, and you can find out what this number would be. So, we're cutting the exclusion zones out of the spatial objects once they're together. Then we just convert the product into a grid. And in this bit, it was quite important that the square is the size of a chair. If you're doing this for an office, you'd want that to be the size of a desk, for example. But this is something we made adjustable for, if we were going to give this to other churches, then other churches could, say, actually, our seats are this big, for example. So actually, before I go to part 2, what I'll do is I'll demonstrate this first bit. This is our St. Bart's Church Building app. I'll click run on this. So here's where I'm going to find my center point. So let's zoom in on London. And this map's taking a little time to render. I do apologize. Maybe an issue of my connection. So this is in Cloth Fair, which is just north of St. Paul's Cathedral. And helpfully St. Bartholomew's Hospital is there. The hospital and the church used to be connected. So here we are in Cloth Fair. And this building here is the church. So what I'm going to do is I'm going to get my point and I'm going to put that where I think that center point is going to be. Accuracy really doesn't matter. It really, really doesn't matter. So my church outline, got my church points data. So I want to select the church outline here. I then want to select the exclusion zones and the church square. I've not talked about the church square because it's not really relevant unless you're specifically doing a church, and even then we thought it was perhaps not that relevant. Now this is just asking for our scale. So what does 1 centimeter equal in meters? So 1 centimeter equals 7.6 meters in the blueprints that we've used to create this data. So I'm going to run that now. And this hopefully shouldn't take too long. Here we go in the file format, building. So here we go. And you can see we've got polygons here. We've got a lot going on there. I'm going to download this as a YXDB file. The grid selector, which we download as a PDF, and I'll just show you this very, very briefly. But basically what this does is it gives you, let's just open on my other side, sorry. So it gives you a bit of a map of your church. So these are all the available seats down here, and they have a number. And the number is useful for when you want to select a center point. So in the minute I'm going to show you, we wanted a center point in the actual church. So you could go, and that would be your first seat, because you don't want everyone to be randomly allocated halfway across the church, miles away from the podium. So this allowed the user to kind of say, okay, here is the first bit, here's the first seat, and that was that. So brilliant. Now that's finished. So we'll leave that for now. And we'll talk to part 2, and we'll use that YXDB file that I downloaded. That's going to be very useful. And now you may be getting a sense of why this was done as 2 separate apps. And that's because, you know, it's a little bit complicated to do that zoom in, to do that, you know, choose what maps to what map each time. It was much easier for the end user to do that once, to then have an output, to have, you know, a spatial object output in a YXDB that they could just plug in. It's much simpler to do that. So that's why we did 2 apps, because we just thought it was really going to be a lot easier for the end user to do that. Now in part 2, there's less steps here, so it looks simpler, but it's not. So first, you know, order the grid, and then we needed to build an iterative macro that allocates the tickets to household, and then filters out every single grid with an X meter radius. So what we're doing is we're saying, okay, here's a household. We're going to give them seats 1, 2, 3. Then every single seat within a 1 meter or 2 meter radius, the user can change that. We used 1 meters. Every single seat within a 1 meter radius is then excluded. We get rid of them so that when we iterate again, nobody can be allocated in any seat that is within 1 meter of another household. That's how we create that social distancing. And then we need to create a map and a table in a PDF format that shows where everyone is seated. So, you know, your church wardens can say, what's your name? Okay, you're in seat 50. That's over there in the lady chapel. You know, that's what we wanted. So here's a little overview of what part of it looks like, the first half of it. So first of all, we just want to clean up the data and select the first seat. You know, as you can see, we've got first seat here equals 600. That makes sense for our church, but we want, if other churches were going to use it, they needed to select other seats. So that's why we made that selectable. Then down, we also wanted to clean up the data with the priority macro. So what the priority macro does, and I'll just show you here. So we could mark people as a priority. So maybe you've got servers who need to be closer to the front or something like that. We could mark them as a priority, and this would find them in the data, and then it would put them right at the top. And then when they're at the top, we could then, you know, put numbers onto these tickets, and it would, you know, always the people in priority were going to be, you know, 1, 2, 3, 4 as opposed to 50, 60, 70. Then we take these 2 bits of data. What we have is ticket data and seating data. They've both been cleaned. The priorities have been established, and we send them both into this macro. What does the macro do? So first of all, in the seat input, we need to make sure there are no nulls coming in. We don't want any nulls. They're going to cause all sorts of trouble. And then we label according to record ID. So we find out, we've got that first seat. So seat 600, we say, okay, that's seat number 1. And then everything becomes gets labeled after that. And we've already done. In fact, I forgot to mention that. In this bit is if you see this purple macro here, what this is doing, and I should have said this, sorry, is it's looking at that first seat and then it's calculating the distance between every single other seat from that seat and then ordering according to that. So you want that first seat to be, number 1, but that's not relevant unless, the seat next to it is 2 and the seat next to that is 3, etc., etc. So that was really important. Okay, so this is then giving the record IDs to them. It's already been ordered, but it's giving it the record IDs. And then in the ticket input. So what we're doing here is we're filtering according to booking ID equals iteration number plus 1. So iteration always starts at 0, the engine iteration number, that is. So we needed plus 1, meaning if you've got your first booking ID, then that will get through on the first iteration. So first iteration, first booking ID. Then when it iterates again, it will filter out to the just leave the second booking ID, then the third time, the third booking ID, etc., etc. So what we want is we want that to go around. And this summarize tool here is just going to figure out the count. It's going to just figure out how many tickets are within that booking ID. So, a household will book together. So the household will share the booking ID. So that's how we're going to know who's in the household, because we ask them to book together. So they share the same booking ID. But it's going to ask how many people are in that household. And then that's going to be sent up so that we so if we've got 3 people in a household, we know we want 3 seats from the seat input. So how we do that? So we append every seat to the first seat. So seat number 1, we've grabbed that out, and we want to know what's the distance between seat number 1 and every single other seat. We don't want to do this by number because, that can go a bit crazy once you get to say seat 100. 101 could be quite far away because, they're being allocated according to distance already. So, as you get a circle kind of going out, so seat number 100 was actually quite a distance from seat 101. Seat number 1 was next to seat number 2, but the further out you got, the bigger the numbers, the more distance there was. So what we needed to do is grab the first seat, work out the distance between that first seat and every single other, and then what we needed to do is say, okay, right, so we've got 3 seats to be allocated to this household. So we want the 2 closest, actually, the 2 closest seats to get through. So then we've got 3 seats. So seat number 1, and then the 2 closest seats to that. And we know that because we've got seat number 3. And you can see here, we just do record ID is less than or equal to count. And that's how we know, because obviously the closest seat to seat number 1 is going to be seat number 1. So that's how we know seat number 1 is going to get through. And so this is what our data looks like. You've got the first data grid, and then appended to that, every other grid, and then you've got the count just at the end. So that's what the data looks like as it's going into this macro. Then once we've done that, and actually I've talked a bit about this already, but we're calculating that distance, and we get rid of every square that is higher than our count. Then we want to combine them. So we want to append. So, we've got 3 tickets. We've got a household that has 3 tickets. We've got 3 seats allocated. We want to append them to that. And then we've already got 2 record IDs. So, one for the tickets, one for the seats. So when we append them, we just say, okay, well, if that record ID matches that record ID, then allocate that one. It's always going to be different. It's always going to be, you know, different for each household, but it's always going to be different for each of those tickets. You're always going to have 1, 2, 3, then 1, 2, 3. So if you have 1, 1, and then there's 1, 2, 3, 2, 1, 2, 3, 3, 1, 2, 3. You just want the record ID that matches. And that's kind of arbitrary, but is also quite clean. It's quite a clean way of just saying, okay, we've given each ticket the 3 seats. Which of those 3 seats they're going to have? Well, it makes sense that the one that matches their record ID is going to be that one, because that's nice and clean. So to finish off, what we do is we then combine those allocated seats with the grid, put the grid back in, and we put a buffer around those seats. So they've got the 3 seats that are allocated. We know exactly where they are now. Those are 3 squares that have been allocated to this one household. We then put a buffer around that. And you can see that buffer here, the buffer tool. So that buffer is dynamic. We set it through this formula tool. So we just say the buffer equals 2 divided by 1,000, because obviously it has to go in as a kilometer. So we need to divide it by 1,000 to turn that into meters. So then that buffer tool uses the buffer that's been input, puts that buffer around. So if it's 2 meters, 2 meter buffer. And then we do a spatial match. So if any square in the grid touches our seats that are being allocated, we get rid. They're gone. So as you can see, the connection, it's very, very small there, but it's the U. In the spatial match, it's the unmatched that goes through. The unmatched then carry on. And what happens is we then send that back to be iterated over again. So when it goes through with the iteration, any seats allocated are taken away, and any seats within a 2 meter distance of those seats allocated are also taken away, so they cannot be allocated to anybody else. One little thing that's going on here, you may wonder why there's these preparation tools, the formula and the max and the append. What's basically going on is we're just grabbing the max number of bookings and appending that, and just sort of saying, okay, if the max number of bookings have been reached, then just stop. And then it filters all the data so nothing goes back, and then the macro kind of says, okay, there's no data, I'm going to stop. This is to stop, if we've not filled the church, we don't want it to keep iterating after that. We've already filled it, so we just want to say, okay, there's no more data left. Then, on the other side at the bottom, we allocate those seats, and obviously with an iterative macro, it unions it. So that is very helpful. So then this is the second part. So I showed you that first part at the beginning of this part 2. This is the second part, part 2.2, if you may. And what this does is this just creates a report. This is creating a table. This is using images, using text. It creates a bit of a text thing. This is, to be honest, all about the pizzazz. This is all about making this very pretty and giving something presentable. As a church, when I was making this, the church wanted their branding on it, so every other church that used it could know where they got it from, who to be thankful for, who to buy, presents for, if you see them or whatever. But this is what this bit is doing. It's just making the presentation, few pictures, bit of branding. And what it's also doing is creating a map. So it'll give you a grid, an output, and it'll say, okay, these are the seat numbers. And then what it'll do is it'll give you a table and say, okay, person, I don't know, Christopher Marland was allocated seat 1. So, people can know, okay, seat 1 is there, and, the wardens can then say, okay, seat 1, you've got seat 1, that's in the Lady Chapel. Before we go on to this, which is kind of finishing, let's have another look. Let's have another demo. So this is our seat allocation app. I'm going to run this. So it asks me to enter the YXDB file produced by the church building app. So it makes it nice and easy. So I'll just go to my downloads, put that in, enter your ticket data. I've got some mock ticket data here on my desktop. Select seat number 1. So I'll do 600 because that's what makes sense for this church. and we'll do 2 meter distance because that's it. There's something I did here, which is an optimizer. And what the optimizer did is it worked out if you shifted the order of tickets of households, which one would fit the most people in. Now, that obviously took ages and ages and ages to run. So, we've got a warning here saying this will take significantly longer. But if you've got a very oversubscribed service and a bit of time, then that might be something that was useful. I've not really spoken about that because that makes quite a bit of sense in a church, but not really if you're thinking of using this in your office, to make sure you can socially distance in your office. You're not really gonna have that kind of motivation. So let's run this, and it will take a tiny bit of time. It is slightly intensive. So let's just give it a minute. Okay, we're good. PDF download. So this is our output. This is our seating plan. And here we go. So here's the branding pizzazz. But here you can see are all our tickets allocated. And if I zoom in, we look here. So we've got some households that are 2 people and some that are 3. So just a highlight, here's a household of 2. Here's household of 2. Here's household of 3. The 2. But you've got that 2 meter distance between all of these. And that's where you get the space maximization here. Let's highlight some more of these. And there you are. So we'll just zoom out a minute. So you can see the seat number here. So 171, 174. So let's have a look. If I go down, got 171, 174. Down here, okay, so here we are. We know that these 4 people who are apparently a household. This is where their seats allocated. So you can look for the name and then see the number, and then you have to find that number within the map. If you sold a lot of tickets or had a lot of tickets booked, that might take you a bit of time. Unfortunately, Alteryx can't make that bit any quicker. Okay. So no, I don't want to save any changes. Back to our presentation. So these 2 here, these 2 blogs, Movable and Rational Online, these are the ones that I use. This Rational Online gives you Earth radius. This is going to tell you that what value you need to put there when you do your trigonometry. You'll say, for example, I'm in London, so I said, okay, in London, what's the value I need to put into this formula? Up here, movable.type, scripts like long, HTML. This is where I got a bit of information about the formulas that I need to use. And Marland data is the blog I decided to publish to accompany this webinar and the previous talk that I did on this. And these blogs you can use if you want to replicate this. Some of the logic is explained there because obviously you can't remember everything I have just said. Okay, so I now have we now have 20 minutes. Time that really well actually. I wanted 20 minutes for Q&A. We've got 20 minutes for Q&A. So let's have a look. We've got a question from Chris Love. Did you think about creating a Tableau public viz of the results? What would be the barriers to doing so? So I think the reason why I didn't do that specifically is I just didn't think there was much interest. I think I could do that. That might be quite a good idea. I'd maybe want to talk to the church before I did that, just in case. But yeah, that might be something quite interesting to put on Tableau Public and see what it would look like. I mean, I can see the use of putting this into Tableau. If you're perhaps doing this in an office and you don't want to put it on the paper, if you've got Tableau Server on your iPad, I could see quite a bit of use in having an interactive viz that shows seat allocation per desk or something like that. I can definitely see the value in that. But yeah, Grant, thank you for that. Wouldn't you have issues when adding new data with Tableau Public? From Lorna, yeah, I think I would. I think if I was going to put that on Tableau Public, it would kind of be a proof of concept, kind of saying, this is what I produce, this is what you can do with this, and this is what it looks like. But obviously, yeah, updating the data would be an issue if I was putting it in Tableau Public. Probably wouldn't be that much of an issue doing it on the server side, as long as you had that all integrated quite well, I guess. But yeah, thank you very much for that. Does anybody else have any questions? I know someone put their hands up at the beginning. I didn't want to be ignorant. So you did have a question when you put your hand up. Please do submit it on the chat or on the Q&A. So where we get the awkward silence, do we know? Is someone typing away or? Oh, yep. Chris Love, are there any use cases you can think of the same method away from seating? Could the same method be used to allocated sales reps to a geography, say? That's actually a really interesting question. Let's have a think about that actually. I can imagine there might be, if you say have a specific quota of, say you want everyone within you want every bit of the country within X mile radius covered, to make sure you don't have overlap. I can see why you might want to do that with a kind of similar app or a variation on this app. I can definitely see that. Yeah. It's the only use case I could perhaps think about that. Where did you learn how to create something so unique from Lorna? That's so nice of you to ask. To be honest, I just improvised this. It was a very hard, I would say, 3 weeks sort of after work. What I would do is, just have some food, and then I'd get cracking, and I'd just do some furious Googling on the trigonometry, thinking how am I going to find this? How am I going to work this out? I eventually found a blog that I've got here, that movable type, and that showed me the formula. If I would do it into Excel. So I just had to translate how to do it in Excel from doing it to Alteryx, which wasn't actually too difficult. And then, yeah, once I'd done that, I just had to, really trial and error and trial and error and trial and error until I got something that worked. My mentor at the information lab, Peter Sylvester, he went through, when I really struggled on the Alteryx side, was working out a way to, say the iteration number equals the, the booking. And he's the one who came up with the idea of using engine iteration number to then use that in the filter. And once I'd got that idea, that was really good. But he took quite an active interest in this, because I think he found it a very interesting academic exercise himself. So, there's a lot of conversations I had with him and a few others who work in the information lab, where I just sort of vented my frustrations and also bounced off ideas. Wonder if you could replicate for football stadiums / theatres for when they allow fans back in. I think you could, to be honest. I really think you could. What I would perhaps do with theatres, because this was a conversation we actually had, because there are some churches that have mezzanine levels. So when I was living in Edinburgh, I went to a place called P's and G's, and they had a mezzanine level. And the conversation we had was when I was talking to them and said, "Oh, by the way, I'm doing this for my church down here in London, if you want to have a look at it." And the conversation we had there is that what they could do is, if there are any seats not allocated, they could run it again, but for the mezzanine level. So they would do it separately, one for the ground floor and one for the mezzanine level. And I can well imagine that you could perhaps work it in a way where you could integrate the mezzanine level. So you could say, you know, anything that isn't allocated to your ground floor, try and allocate it to this new other spatial object for your mezzanine level or for your upper mezzanine. But yeah, that was what we were going to do for the church, but I think you could do it a bit smarter if you were a theatre or a stadium. Do you have any more questions?
Sorry about me posting them in the chat there, Chris. I don't have access to the Q&A with being the host. I think it's an absolutely fantastic idea of what you've actually come up with, and it's so complex it literally blows my mind. And I think it blows Chris Love's mind as well, which is a good thing.
That's hard to do. That's very hard to do. Wow. No, that's flattery.
Yeah, he says brilliant. Yep, it blows his mind. So definitely, it's a great use case, and I'm sure there's lots of other companies that will definitely want something like this, especially if they're going back to offices and like I said, fans going back into stadiums. This could help them a lot with trying to figure out that social distance thing. So thank you very much, Chris. It's been great to have you here. And if there's no further questions, we can close out. But thank you everyone for joining. The recording will be made available on our YouTube channel by the end of this week. So do look out for that. And if you have any other questions, reach out to Chris via Twitter or drop us an email here at the Information Lab.